So I'm going to use a data set that the MME and VC guys used for exam, just to take you through the process. Just close some of these things. So I'm going to be sharing from my screen. It makes it easier when you do SPSS. Okay, so what I'm going to do now, I'm going to go through the process of data analysis, where you start and how it goes. I'm gonna keep an open, clean, open sheet here that we can write as we go along. So there's a paper that we are working on using this data. So I'm going to use this just to give a sense of what we are doing. So we're going to be looking at resilience and how resilience influences performance of a business. So there are different dimensions of resilience, and this is what is going to guide us then to do the analysis, just to give you a sense. So we'll look at these different dimensions of resilience and look at how each of them influences business performance or business growth. We'll just use one for illustration purposes. So that's what we are going to use. So we've got a hypothesis that we have is a hypothesis that says resilience influences business performance. Just go back to the empty one. Okay, so this is what we are testing. Let me just save this so we don't lose it. In case somebody wants it. Okay, so we've got this hypothesis that we need to, let me say resilience dimensions, because we've got more than one item. So what will be our step one? What are we going to do first?
Identify your dependent and independent variable.
Okay, so what is our dependent variable?
A dependent is resilience and independent is business performance.
Okay, think first before you talk and say that again.
Our independent variable will be resilience dimensions, and then the dependent variable will actually become business performance.
Yes, and why is that? So explain how you got to that, to decide which one is dependent and which one is independent.
Because any changes in the elements of resilience would actually create changes on business performance.
Yes, but changes in business performance don't change resilience. So resilience is to change, is not dependent on business performance, but business performance is dependent on resilience changes to change. So that's why we say business performance is dependent variable, because it's dependent on the changes in resilience. And I know most people always do this quick without thinking, and then you mix it up. And then we've got independent variables. So it will be multiple because we're going to be looking at the different dimensions that I show you. And then it's going to be resilience dimensions. Okay, so we've identified that. Let me just make it one thing. Okay, so we know what's our independent variable and we know what is our dependent variable. What's the next step?
Is to come up with objectives.
Okay, let's assume that we've already done the objectives in chapter 1. We are now in chapter 4. So we've already done, so the objective was that we want to investigate the level of influence that resilience has on business performance. And our research questions is at what level does resilience influences business performance? So we're done with chapter 1. We've hypothesized in chapter 2, so we came up with this hypothesis that says resilience dimensions positively influences business performance. That's what literature told us. We've decided in chapter 3, that the methodology we are following is quantitative, and then we are going to do multiple regression, so that we've decided already in chapter 3. We've decided that the measurement scales that we are using for both dependent and independent variables are multi-item scales. We're using ordinal data and we're using 7-point Likert scale. So we have done all that up to chapter 3. So we are in chapter 4 now. So we want to run the data analysis. What next do we do?
First, have to clean the data.
So we need to clean the data. What do we look at when we clean the data?
Any missing cells?
Missing. What else?
Isn't there coding to code according?
Coding errors. Anything else?
What do you call it when you change, like you strongly agree and stuff to numerical?
Reverse scales or codes, whatever you call it, or questions. Okay. Then once we've cleaned the data, what do we do next?
Import into SPSS.
No, Lashana, I don't want you to be the only one talking. I know you've been through this already, so you know. I want the other guys to give it a try as well. I'll take that, but someone else must respond. Import to SPSS from Qualtrics. You used Qualtrics. If you didn't use Qualtrics or you did manually, you'll have to record onto SPSS from your manual papers, or if you've got Excel, then you have to import from Excel. SPSS. So here it depends what did you use to collect your data.
Dr. J, can I ask you a question on that?
Yes.
Do you import first to Excel before you import to, export to SPSS, or do you directly do it from Qualtrics to SPSS? And if you do that, the cleaning of data, do you do the cleaning of data on Excel first before you export it to SPSS, or you can move everything to SPSS and clean the data there?
It's all about your preference. But if you collected your data on using Qualtrics, my recommendation is that you export directly to SPSS. And why is that? Is because it's gonna keep your coding intact. You don't have to recode. But the minute you take it to Excel, when you take it now, because remember Excel is not multidimensional in terms of the information it keeps. So what Excel will do will just take the 1 to 7 that people chose and selected when they were answering as plain as like that, and then now when you move it to SPSS, now you have to get to SPSS and sit and code again as to what 1 means was 2, 3, 4, 5, 6, 7. But when you take it directly from Qualtrics to SPSS, it keeps the coding. So remember on SPSS, you've got 2 platforms. You've got the variable side and the data side. When you go to the variable side, you will see that already you've got the part where it shows that 1 is a strongly disagree, 2 is a strongly agree, and those kind of things. So it's better to export it directly as SPSS and clean it there. Then you don't have to do the coding. Yeah, unless you feel comfortable with cleaning it on SPSS, but then you have to take the fact that you've got extra work to go back and recode onto SPSS. Yeah.
Okay, thanks.
So Excel comes into play. If you did it in Qualtrics, you don't need Excel really. But if you collected manually, let's say you printed and gave people your questionnaire to complete, then what you need to do now is, because you need to capture that. So you need to capture, it's easier and quicker maybe to capture it on Excel, because even if you capture it on SPSS, you still need to code it anyway. So you'll find that some people then will have it on record it on Excel and then export it to SPSS and then start doing the coding there. Some people, you find that they prefer, they didn't use Qualtrics, they use other softwares that are not compatible to SPSS. They can only download it into Excel. Then when you get to SPSS, then you have to code again. But if you use Qualtrics, which is recommended, saves you that time, then you don't need to record, especially if you spend the time before going to collect the data and checking that your instrument and everything was done properly. Okay. So now we've exported it to SPSS, so we are there now. What's next?
Would you run, that analysis to check if, to check the missing values and determine whether those missing values are sort of like at random or sort of like IQ to system bias?
Okay. So what we are saying is that we're supposed to start with importing. Yeah.
Well, in my case, it will have to be, we have to do the importing, and I suppose because my survey is done on Qualtrics, it'll be just importing from Qualtrics to SSP and then doing that analysis. To check bias and randomness of the missing values.
Okay. Yeah. So you start with, if you are on Qualtrics, you start with exporting it. Then when it's on you are on the SPSS platform, then you do the cleaning. And then when you are done with the cleaning, what do you do next? Sebastian?
You need to check the reliability of your scale. So the instrument that you use, how reliable was your scales on your instrument? So for me, I did that Cronbach Alpha.
Okay, let's see if you are right in that. Let's remember the chapter 4 structure. What do we have in chapter 4? Because the sequence you have in chapter 4 most of the time is what is going to happen as you do your analysis. What is it we are missing that we need in chapter 4? So we have cleaned the data. What is next in chapter 4?
Am I correct in assuming that your data cleaning involves a screening as well?
Yeah, data cleaning is basically screening. Okay. It's just terminology. Some people talk screenings, some talk quality of data. So different reports will use different terminologies. But after cleaning, there's something that comes that you need to present in chapter 4 before you get to your reliability and stuff.
Your characteristics of your...
So your sample characteristics.
Sample characteristics, yes.
So here is where you present your demographics. So you might have individual data, maybe, and business. So all of you are doing business studies, so and business data. So this is where you're going to tell us that I collected data from 20 males and 40 females. There are 50 CEOs or 10 entrepreneurs and 5 managers and whatever. This is what you present first, sample. That's your sample characteristics. Okay, so when you're done with sample characteristics, what comes next? Ronald, welcome. I see you've joined us. What comes after sample characteristics? I know we have read some theses.
Thank you for welcoming me. Okay.
Yes, what comes after sample characteristics in chapter 4? Who wants to try? Anyone?
Your validity of your constructs.
Okay, so you start with your validity. And then the next one becomes your reliability. What are you testing on validity? What are you checking, and what test techniques are you going to use there? Okay, maybe let's start number 4. When you do your sample characteristics, which tab are you going to use on SPSS? Which test techniques are you using there?
Dr. J, is that the question I asked you at the beginning?
Come again?
The technique is the question I asked you in the beginning, am I right? About the comparative cross-tabulation.
Okay, that's when you decide to be fancy, but there's a basic one. I'm looking for the basic one before you get fancy.
Isn't it the distribution, Dr. J?
Yeah, so you're gonna use descriptive stats.
Mm. Okay, yeah.
That's where you're gonna use your frequency tables and graphs. That's what you use here. And then if you decide to be fancy, then you can go use your cross tabulation. Or cross tabulation, what it means is that you don't want to present, let's say you've got males and females, then they've got certain level of education. You don't want to have one table that shows that you had 50% male and 50% females, and then go to another table and show that you had 50 people with PhDs and 10 with undergrad. You want to present both the gender and their level of education in one table. Then that's what we call cross tabulation. So you cross tabulating different things. So it's in one table. You show us the percentages in terms of the gender, but at the same time within the gender, you show us their level of education. So that is cross tabulation. So those are the guys who are comfortable, who wants to go fancy. But if you want to just go plain, you run your descriptive steps, and then you've got your frequency table. So you can either use bar charts, or you use a table, or you use a pie chart and those kind of things, but you use one. I've seen some who show the table and the graph. It gives the same information. So you need to make a discretion as to, will the table present best what I'm trying to say, or will a graph present it better? And then which type of graph will do it better? And then you choose. So normally then you'll find the pie charts, you'll find bar charts, and then the tables. So you choose from those. So that is the test technique or tab that you're going to use from SPSS. And then for validity, what are we trying to achieve there, and which test technique are we going to use there? And mostly here we focus on construct validity. There's a lot of other. So which test technique are we going to use there? Guys, have you done chapter 3?
Dr. J, I'm just going to take a plunge. In terms of construct validity, aren't we testing the relationship between measuring the relationship, the efficacy of the relationship between your independent and dependent variable? And based with that, I would suppose that we do a correlation.
No, we're not there yet.
Oh, okay.
Not there yet. Has anyone done chapter 3?
Yes.
And what did you say in chapter 3? Because what we are doing in chapter 4 is what you promised you're gonna do in chapter 3.
So you're gonna run a factor analysis.
Wait,
isn't it factor analysis?
Wait, guys. Wait. Raise hands so that I can see who's talking. Who wants to talk? Kathy.
So with construct validity, we trying to see if the test measures what we said it would measure.
Okay, that's true. Then the next question is, which test technique do we use there? Soli?
I'm thinking more, Dr. J.
Oh, I saw your mic is on. I thought you want to talk.
No.
Wouldn't it be factor analysis where we checking those constructs, Dr. J?
Yes, that's factor analysis. So here then you could do exploratory, which is sometimes referred to as EFA. So some do component. And then some who wants to go fancy, they also go for CFA and confirm those factors. But if you can't remember the test technique, leave CFA, just do EFA. Okay, and then once we're done with construct validity, then we go to reliability. So which test technique do we use here to measure our reliability? So it's mostly scale. We look at the scale, and we looked at internal consistency. Okay, who wants to try? Which test technique are we using here?
Cronbach's alpha.
Yes.
Okay, so we're gonna use. Okay, then after that, what do we do? Who hasn't spoken? Who wants to try? Shaylee? Shaylee, do you want to try?
Dr. J, is it not data processing reliability or the instrument reliability?
Yeah, that's what we did in number 6. So the scales that you test reliability for is basically from your instrument. That's what we are checking. Once you're done with that, what do you do next?
Is it now not presenting the results, like findings pertaining to your hypothesis?
Yeah, but we haven't done that, so we can't present it before we do it. So that's what I'm trying to get. We're now looking at what we need to do. So you've got your reliability testing. What's next?
Wouldn't the next stage be your correlation analysis?
Okay, but before you get there, there's one step that is important that some people forget. After these two, there's an important step that comes in there so that you can have variables that you can use for correlation.
Your factor loading.
Yeah, what do you do with those factor loadings? You've got factors, you've tested that the items within them are reliable, but now you want to remember the whole objective of doing the construct validity and the scale reliability is that you want to reduce the dimension of your data. So if you had 5 items measuring innovation, you want to change that to have one thing called innovation. What is that step? What's this technique do we use that so that we change the multi-items into variables, into one thing that we can measure? Lashan?
We work out either the mean or the composite scores.
Yes, so you do your composite score. And for those guys who did MME and VC during the exam, most of you skipped this part and started analyzing, trying to test your hypothesis with the same dimension of data dimension like you had before you did your factor analysis. So the objective of doing factor analysis and doing the scale reliability is to reduce the dimension of the data. So if there was 5 items for innovation, you take an average of that. Different people use it differently. Some use average, some use median, some use the sum. I recommend the average, the mean, because mostly we're assuming that our data is normally distributed, which we will check later. So you take that. So if you had 5 factors and each of the factor had 5 items, so that means you've got 5 times 5 in terms of the variables you have. And that's not what you want to measure. You just want the 5 factors to represent a specific construct and then be the variable that you measure. So you do your composite score.
Dr. J, In one of your videos
then-
that you shared with us, you mentioned about standard deviation in measuring respondents that were unengaged. At what stage do you do that?
Oh, that will be at here, cleaning.
Okay.
So you've got incomplete, you've got missing, you've got unengaged respondents. So what do we mean by unengaged respondents is when you've got people who just tick and they don't apply themselves. So you find a person is just got all his answers are 7, or they are all 6, or he just keeps swapping between 7 and 6 or something like that. Then that shows the person did not apply themselves. And one of the things that you do proactively to manage that is by doing the reverse questions. And then if the person is not reading the questions and just ticking, you will find that even where you reversed, where it's supposed to be a 1, she'll still choose the 7 because it's not reading the questions, it's just ticking. So here you find you will have a very low standard deviation. And then also you apply yourself and see, did this person apply themselves? Or is it just coincidentally that maybe really the answers were all close to each other, and then you decide and then you can take them out if you feel they were not applying themselves. So here on SPSS, you're going to use the tab that is called transform data, or data transform or something. So that's what you would use there. And then now, after this, now you've got, instead of having 25 items, now you've got, let's say, 5 factors, and those 5 factors becomes your variables that you are going to test. And from those 5 variables, you will have your dependent and your independent variables. So what do you do next now? So you've got your composite score. Those are the variables that now you are going to be using. So this kind of like factors changed to variables, which then you will have your independent variables and your dependent. So what's next? So remember when we started, so don't forget that we're doing all these steps to get to this. This is what we want to eventually do. So keep this in mind. As we do all these steps, we want to get to this objective of testing this hypothesis. So we are now on step 8. What do we do on step 8? Tuli?
Dr. J? I'm really just following here because this is the section that is a challenge for me.
Okay. You don't want to even try. We won't kill you if you get it wrong.
So I'm not familiar with SPSS. So I really don't know. I don't know what would be done on SPSS after this.
Okay, that's fine. Sebastian?
This is your correlation analysis.
Okay, so why are you doing correlation analysis? Because there's a heading for that as to why we're doing that before we say correlation analysis. Ronald, you want to try?
We are now. Mike is not.
We can hear you. You muted yourself, so start afresh.
Yes, I'm saying we are now testing the hypothesis. So we can do a regression analysis. That's what I suggest.
Okay, before that, before the actual regression analysis, there's something we need to do.
Yeah, I think maybe I missed that. I just joined in now. I'm just trying to follow. So
okay, that's fine.
Don't we look at what the connection is between the variables?
Before we get there. It's part of the regression, but there's something we need to check before we can be comfortable that we can do the regression.
Is it assumption testing?
Yes, so we do assumption testing.
Do we do that before correlation or after, Dr. J?
Correlation, if you had a hypothesis that where you needed to test correlation, you can start with correlation. I mean, when you test, if you were testing relationships as well. But if not, then you can go to the assumption testing. Because remember, as correlation becomes the assumptions that you need to test. So in terms of the thinking, it becomes assumption testing, but in terms of how you present it in the report, you can present the correlation table first and talk to that, but it falls under the assumption testing. What assumptions are we testing? So when we do correlation, what assumption are we testing there?
Are we not testing what we stated in our hypothesis?
Not yet. So our hypothesis was not about relationships. So if our hypothesis was about relationships, then the correlation will talk to that. But our hypothesis is about influence.
Is it, what is it, a causal relationship between the dependent and the independent relationship?
Carefully use your words. Causal, relationship, influence, those things are not the same. You can only do causality if you've got longitudinal data.
Okay.
Is assumption testing, Dr. J, you're checking if none of the assumptions are violated so that you can run the regression?
Yes. But what are those assumptions? That's what I'm looking for.
So one is like no outliers.
Okay, so I'm going to test outliers. What else? And here, testing outliers, you can use box plots, which I find is the easiest one to use. You can use standard deviation. You can use Mahalanobis. There's a lot of them, but box plots is the easiest. Okay.
Normal distribution.
Test. Yes, and linearity. So the correlation that you're talking about, that helps you to test linearity. So normal distribution. Remember, our starting point is the standardized. We start with the standard distribution. So here you can use descriptives. You can use histogram. You can use
Can you use the bell curve there, Dr. J?
Come again?
Can you use the bell curve?
There?
Bell curve.
Or bell curve, that's your histogram.
Okay.
It will show in your histogram, yeah. What's this one that I'm looking for? You can use QQ plots. There's many things you can use here. You can use Levin, no, not Levin. Those funny names, I forgot those guys' funny names, but yeah, I'll remember them. Smirnov something, Smirnov, and Komolov something. I'll remember the names. Which one works? Descriptives. I find descriptives. I'll just highlight. I find descriptives the easiest. Everybody can interpret that one. Those blocks easiest can interpret that one. Correlation. You can use the what do you call that graph? What is this graph that's got dots?
Scatter
plot, yes. It's a long weekend, so all these words are going. I was saying to Tulu when she reminded me to send the link that I can't believe myself that I committed to be busy with you guys on a long weekend. I really regretted it, but anyway. What else do we need to test? So we've got outliers, we've got linearity, we've got normality. What are the other things we need to test?
Multiple correlation.
Collinearity, that's if you are doing multiple regression. Linearity. So it's like when you've got your correlation greater than or equals to 0.9, where you can have singularity, where two variables won't give you any different information. So it gives you the same information. So you don't want that. It's multicollinearity. So that this is applicable if you've got multiple independent variables. If you've got only one, it does not apply. So, but basically what you are looking at is if you're testing an influence of two independent variable onto a dependent variable, does these two independent variable each give you different information? If it's 0.9 or 1, then they are perfectly correlated, so they don't give you any new information. You can let go of one and just use the one. What else? Your errors needs to be normally distributed as well. What is the other thing we're testing? So your errors normally distributed, your observations needs to be independent. So these are all the assumption testing that you'll be doing, but the most important ones that will mess up your results, your outliers, linearity, your normal distributions, those you need to make sure upfront that you're good with them. So normally in terms of presenting your results, in chapter 4, you might find that in your section after you're done with composite score, here you want to present maybe your correlation with the SD and the descriptives. Then you'll already from here see your normality and stuff. Okay, so we're done with assumption testing. What's next?
Dr. Jane, some theses that I read, they used missing data and sample order also under assumption.
Yeah, it is an assumption that you also need to make sure you don't violate, but it's no point to work with missing data until you get to this point. That's why it's better to just clean it up front, because otherwise then by the time you get here, you've done so much work and only then you start cleaning it.
Okay,
put those ones up front to deal with them here, but then it is something that you must not violate as well. It's an assumption that you can state that we have addressed it in during quality or during the screening. Okay, so we've done the assumptions and we find that we are not violating any. So what do we do next? So then now you do what you've been doing all these things for, hypothesis testing. So you bring back now what you said you wanted to do here. So you do your hypothesis testing. So you're going to present your tables that you get from the regression. So to do your hypothesis testing, obviously the test technique you use now is your regression analysis. Because we assumed that we are not violating any of these assumptions, so we will do linear regression. But other regressions that you can do, which you were asking me about, Lashan, is if you are violating some of these assumptions, then you'll have to check the characteristics of your data to see which one fits this. But most of the time, if you violate these ones, then you will go to non-parametric testing. So what we are doing now is what we call parametric testing. And what parametric testing assumes is that your data resembles a normal distribution, which got standard estimates that you work with that everybody knows. But if you violate this and then you go to use other different types of regression or of analysis, then those people tend not to trust them much, because there's a lot of unknowns behind them. That's why what we normally do, if you find that maybe you violate some of the things or you violate normality, you'll try to transform your data so that it meets the normality assumptions, because that's the easiest and most reliable testing that you'll ever do. I'll show you when we run the SPSS some of the things that, some of the different types that you get from SPSS that you can use, but they're mostly not popular because the linear with normality tends to be common for parametric, and then anything else will tend to go outside non-parametric. Okay, so we've now mapped up the process of what we need to do. So now we're going to go and do this now on SPSS. So remember, we had all this. It's just that it will waste time for me to go and write each of these as sub-objectives, but it will come out as we do it. So the first data set that we had, we'll look at this, which was not cleaned, which is been downloaded from Qualtrics. So remember what I was saying earlier, that if you take this directly from Qualtrics, then you'll have all the coding in. But before you get there, obviously, you've got all this information that you need. You will have to delete whatever that you're not going to use, because it's just gonna make navigating your data easy. So you delete whatever that you don't need. So things like this. Then if you right click on something, you can delete it. Where is it? Here. Okay, let's go on to the variable side. So if you right click on that, you are able to delete whatever that you are not going to use. So this becomes the first step where you're doing your cleaning. So We did not say it. It's not necessary really to state it, but that's one of the things you will do in your cleaning. You delete whatever that you have that was recorded that you don't need, like IP addresses and stuff. So you're gonna delete all those things. So if you look here on the values, if you moved this from Qualtrics to SPSS, you'll have this part empty. But because this was moved directly, exported directly, then you are able to see the different codings that you have. But if it's from Excel, it won't have this, which means you will have to come and edit and do the coding yourself, which can be time consuming. But if it's directly, then you've got all the codings there for you, then you don't need to worry about that. So that's what I was meaning, that this is the benefit of moving it directly from Qualtrics to SPSS, because then you've got all your codes in there. Okay, so some of the things that you want to during your cleaning, so like it gives you just questions here, question numbers. What is your question number? But what you don't want to present this in your report as question 1.1 or question, have a table that presents this like this, because it's useless for whoever does not know what question 1 was. So what you do then in the cleaning process, you look, okay, question 3.9 was gender, and then you come here, then you change this into gender, and then your table and your presentation of your results then will refer to your variable as gender than question number. You do the same, this was level of education, and then you will come here and then change to level of education. And then now you've got clear things in terms of what each of these things present. So that will be part of your cleaning. And then in terms of the data view side, then that's where you will check then people who completed. For an example, you look at this one, having completed a lot of the variables, so it's not worth keeping. Then you start deleting this ones. You can do a cutoff for yourself to say maybe my cutoff 10% is up to question 17. So anyone who hasn't responded to anything from this side, then you delete, and then you do that, and then go one by one, and then delete the different items for those that's got empty ones. Obviously, you will have deleted all these ones that you are not going to use, and then after that, then you check who went up to a certain point, who do you keep and who do you delete. So for the ones that you find that there's a few that they did not complete, but completed most of the questions, that's the one then that you're gonna go and use the replace missing value. And then you can decide, you choose the question that you want to replace the missing value with, and then you series mean is a common one. Then you decide that you want to replace it with series mean for whatever that was missing. When you say okay to replace that, then it goes onto your data set, and then it adds an extra variable of the variable that you've added. So if you go to the end, you will see that now you've got an extra variable that now has got the series mean. So if you look down on this one, you will see you have no missing value, because then you added the series part. So you do that, you'll find that now you've got duplications of question numbers. You'll have to go back and rename them based on what now you're going to be using. So it tells you here, this is the one we added, which is a series mean, and then you'll have to rename and create a new data set and delete the one question 4 that had missing value, and keep this one and then rename and all that. So that is the cleaning part where you substitute some with series mean. If you don't need to substitute with replace with series mean, then it's fine. You delete whatever that's got too much missing values, and then you find that then at the end of the day, if you started maybe with a data set of 437, after you've deleted all the missing, maybe you end up with half the data set. So you make the discretion yourself in terms of that. So I'm not going to dwell on this one. Yes.
When we're deleting, when we're working out the 10%, do we take the demographic questions into consideration as well in the 10%, or is it just your linear scales?
No, so you don't because the demographics don't change your analysis. So when you look at what is missing, you leave the demographics. You look at your independent variable questions and your dependent variable questions, because that's what you're gonna do regression on. You're not gonna do regression on the gender and other things. And then those are the ones that must not violate the missing value rules. So those are the ones that you address.
The other question is the name on the data view. Is there a maximum length, or can we just name it as we please?
Which one?
The one where you change Q1. No, on the next there, the name. Is there a length, or can we change it to what we feel is?
Yeah, you can change it to what you feel is fine. I think there is a limit, but I don't know. You will see, it will tell you when you went too far, but I think there is a limit. But what you need to remember also here, you see the label site, there's spaces in between, but you can't have spaces under name. That's why I put this underscore, because if you try to make a space here, it will tell you you've got an illegal character. So whatever names you have here, if you've got two words, you separate it with the underscore. Otherwise, it's not going to accept it. So it does not like spaces, but on the label side, it accepts spaces. I don't know why it does not want to accept it here. So if you look also all the names that came from Qualtrics, whatever was two words, it just made it one word. If you wanted to make it easier for reading, then you just put the underscores so that it's readable. But once you've got your output files, because when you get output files, you are able to edit them afterwards. So when you get to your report, to make it clean, you can go back and take off the underscores and present it as a proper two-word phrase. Okay. Any questions on the cleaning? I'm going to move from this one because I think this is more your discretion and common sense in terms of what you delete, you keep, and all that, following the rules. And it's basically deleting and changing words and all that. So there's no statistical skill really in the cleaning part. It's just know the rules, delete whatever you don't need, rename what is not presented as you wanted, replace with series mean those that you feel that they've got less than 10% or they don't have too much missing responses, and then that's all. And then in terms of some of the things that we stated, so you look at incomplete. Incomplete is those that stopped in between. Missing values is those that skipped certain questions. So, but more or less, you will also check both of them, whether it's 10% or it's too much, and then you delete. And then coding errors, these ones you check by looking at the variable site, and then you come here, and then you look, maybe your strongly disagree was supposed to be 5, and then it's 1, then you can edit and change that and check all of them. But I always recommend that you do this before you even collect the data, so that when you get here, then you don't have any coding errors. And then the reverse scales. This one, if you know upfront what you've reversed, you can summarily reverse it at this stage. But some of them, it will show up. If you forget it, it will show up when you do exploratory factor analysis, and then you can then change it then. The unengaged respondents, you can always go to your you can always go run your descriptives and check SD for each of the variables, and then it will give you an idea which one have got too low SD, and then you start checking them whether the person just SD that is 0, that one is a no, you have to delete it. And then at the other smaller ones, then you can start using your discretion and see which one you think the person applied themselves, it's just the SD is low, and which one you think they did not apply themselves, and then you delete them. So the SD will be an SD of a respondent. So you get standard deviation for an example, respondent number 8, respondent number 42, and then you make a decision from that as to whether they were engaged or unengaged. So that covers the cleaning of data. Importing
Dr. J, where do you go to get the SD on SP?
You can do it on the descriptives. So if you go to analyze your descriptives, you can choose your standard deviation there. Then it will give you the standard deviation. Okay, so but then you have to say which ones you want to check. So let's say, let me just do one. So let's say you want to check these 5 questions that looks dodgy. You want to see, and then you'll go here. We don't want the minimum and maximum. We just want to see the standard deviation, and then you go continue, and then it will give you the results, and then we are able to see here what each of them, what the standard deviation was. Oh no, this one gives you the questions. So what you can do, sorry about that, what you can do for each response, because you don't want for the question, you want for the respondent, you can go and do the, okay, I haven't done it here. I normally will take it and just check it from, I think I can do it here, let me see, compute. Yeah, it will give you for the question. Just download this on Excel, and then what you do when you get to Excel, because I normally just use my common sense. I haven't really run it on SD. So you'll have, let's say, respondent 1, respondent 1 up to maybe respondent, whatever the ones that you want to check, and then you'll have their questions, maybe question 1, question 2, question 3, and then you can do your standard dev here. And then let's say the person choose 777. And then I think they've got an automated one here. Yes, GD. Yeah, so then you can just do it quickly on Excel, and then it will give you. So like if a person has some variability in their answers, then you will have a better standard deviation than a person who has responded to all questions the same. So obviously you will know that the 0 standard deviation, you don't want that guy, you're gonna go back and delete him. And then the others that you get, then you make your discretion as to how it looks like. Did they apply themselves and all that, and see more or less their answers and decide. Okay. So that's the unengaged respondents. So that is that. So then one thing that you add there is delete all useless variables. But this I'm just doing for you to remember, but don't present this in your data. It's not worth the master's degree that you need to get. It won't give you any extra mark. You do it, but you don't have to talk to it. You can talk to the other ones as to how you address them. Okay, so that was your cleaning of data. Any more questions there? So now we go to sample characteristics. So now I'm going to use the data set that I've already cleaned. Okay, it doesn't want to open now, it's tired. Okay, so we're going to use this one now. So I've cleaned this one already, so it doesn't have missing values. We started with 300 and something. The other one that was not cleaned, we started with 300 and something. So we ended up with 200 and something for after cleaning it. So if you look here, we don't have any missing data. You will see that on the demographics, you will still have missing data. So what are we doing now? So we are now doing our sample characteristics. So we're doing this part. So when you do that, remember we said the technique that we're going to use descriptives, frequency tables and all that. So we're gonna go to analyze. And also this one on the variable view, I've already changed, renamed the question numbers as I was showing you. So I've already named them to what the question numbers were representing. Don't worry about this part, is because I've already ran the analysis, the exploratory factor analysis here, but we will redo. So what we want to do now, so in chapter 4, so you'll have 4.1 as your introduction. You've got 4.2 as your quality of data or data screening. And then you're gonna have 4.3 as your sample characteristics or demographics. So that's what we are doing now. So you go to descriptives, you've got options to go to frequencies or descriptives. The descriptives, this one I normally use when I do normality test because it just gives you a pure descriptive, but here I'll also be able to get the graphs that I want. So our demographics that we want to present, let's say we want to present up to there. And then you need to decide what you want to see. We don't want to see all this. We just want to see the tables and the graphs. So let's use bar charts. So we've got options. We want to use bar charts. Do we want it presented as frequencies or percentages? Let's present it as percentages. Display frequency tables. Do we want it APA style? No, it's fine. The normal one with all the colors are fine. And then you run that. So our descriptives, we wanted to see the gender, we wanted to see the level of education, their age, race, and whether they are intrapreneurs or not, and their intrapreneurial experience. I think that was that. So then it gives you that. You see, we still have like 2 who chose not to respond in terms of their gender. Is fine because that does not affect our regression. We keep it like that. So when you report this, you don't go and just state as it is. You bring out whatever that you want the reader to pay attention to, which has some material meaning into your analysis. So looking at this, you've got 56% of them being male, and then you've got 42% of them being female, and then you've got about 0.7 who chose not to respond to this. So then what you will communicate is that from the sample that you have more than 50% of your respondents being male, and then you state the 56%, and only about 0.7 chose not to respond to the question, and then that's fine, you leave to that. You come to here, education, how do you represent that? You look, more or less, we've got a bit a higher level being honors, but if you were to combine, so you've got about honors, 26, 40, maybe you can present this together to say you've got postgrad of 2 for about maybe 40 plus, and then you've got just undergrad of maybe you combine that. So you present in a way that brings in information than just go and say less than 0.4% had less than high school, 8.9% at high school, 17% at diploma, 23%. That is something that the reader can read from the table, but you want to extract what looks more insightful and then summarize it and present it like that. You do the same in terms of age. Maybe you want to present it as youth. You say, okay, we had about more than 30% that was youth, and then we had about 40% or so more, which were between 35 and 54. And then we had the old guys, which was 8% or so. So that's how you present your demographics. You go to race, you do the same. You can present that most of the respondents were Black. And some of the mistakes that I saw in some reports that students do, like for example, if you look here, there's no category that represent most. It's more or less around the same thing. So you can't go and say most of the people were 35% because it's less than 50, so it can't be most if you're looking at over 100. But if you look at the race, 85% are Black, then you can start talking about most of the respondents were Black, and then about 8% were white, and the majority fit into the other categories, which all of them were less than 3%. That is more meaningful than you just go and say 8.5% were white, 85.5% were Black, 1.8% were color, 2.5%, you're saying what is in the table already. So that's how you write your report. And then between the tables and the graphs, you decide which one present what you want the most. Don't do, let's say for race, you choose you're gonna use a graph. You can't use the table as well. So you choose for race, I'm gonna use the bar graph. For whether intrapreneur or not, this is not helpful. I'm just gonna say it. And because this was one of the exclusion criteria. And then you say, this one I'll want to present it using the table, is too messy like this, and all those. So those are decisions you make. And then that covers your demographics part of your report that you need to present. You've got an option to edit these things. If you want to edit, you just double click on it, and then we are able to edit, maybe rename certain things the way, but don't tweak the results, because then we are cooking the books. You can change any labelings and stuff, but don't interfere with the results. Then in accounting, they call it cooking the books. And in terms of the graph as well, you can double click if you want to change colors and all those kind of things. You can do that here. And then when you close it, whatever that you will have changed then will change on the actual graph on the other side. So if you want to play with colors, make it look beautiful. You want to change maybe the text at the bottom, you can click there and change it. So those is like you now really getting fancy. Any question on running demographics or presenting or before that? So if you decide, Lashan, that you want to go the cross tabs, you've got cross tabs here. So this is your cross tabs. Then you have to decide, okay, I want to present gender, maybe and race together. And then you can do that. Then when you get your table, now it will be given to you in different format. If it's just presentation, you're not analyzing, you leave all the other stats, but then you can decide in terms of percentages what you want to be shown where. So you play around here. And then also in terms of the format, it's fine. So you play around with here in terms of what you want to present. So you'll play on the percentages here and the counts here. That's what you will play around with. And then that's where you can do your cross tabulations. Okay, any questions on 4.3 demographics, sample characteristics? Okay, we're all happy. Okay, so what is our next step? So we've done, let's call this 4.3, just so it makes sense. This, so that you see this is our chapter 4. Ask me questions while I try to get this to make sense.
Dr. J, is there a page limit for chapter 4?
Come again?
Is there a page limit so that we don't get carried away with the descriptives and stuff?
No, there's no page limit.
Okay.
Can get as excited as you like. But don't get people tired with descriptives, then they don't get to your part where you really want them to pay attention to. Okay, so you'll start with your intro, you clean your data, and then you do your demographics, which is what we just did now. So now we go into your validity. Okay, and then after your validity, you're gonna go. I'm just trying to do it like this so that you see where it fits, is gonna fit in your report. Because the structure is very important, that you get it to flow and make sense. but use the right headings. So I wrote them in a way that you can understand. So now we're gonna go on our construct validity. So we've done the sample characteristics, then now we need to look at the validity. Okay, so, okay. So what SPS has done is it does as you run your analysis, it saves your analysis on what you call output file. Don't make a mistake and close it without saving, because that's where you're gonna copy paste into your report. If you want to make it easier for yourself, you can save it as different. Let me just put it somewhere desktop. You can decide to save it. Let's say you say output one was all your sample characteristics, so that when you come back to copy paste, you know where is what, otherwise it becomes too long. So we've done sample characteristics. So then we're gonna close this output file. So now we go to the next step. Now we're gonna do our construct validity. Okay. So remember we had the different variables. We had business performance, and then we had resilience dimensions. So if you look here, from here up to here is all the business performance and business growth. Remember we had two dependent variables, but we're just gonna use one for practice. So these are all the items or all the questions that relate to business performance. And then from here, then now you've got all the dimensions from 20. You've got all the dimensions for resilience. It's a lot of them. Up until 75. These are all the dimensions for resilience. So what I did to make it easier for me to relate, because I don't want to keep on going to check what the question was, what I did, I numbered them. So all the ones that were asking about hardiness, I numbered them, gave them the same word hardiness, but then with different numbers. And the same, all the ones that were about uncertainty and ambiguity, I numbered them accordingly and all that. So it makes it easier in your factor analysis to see who has loaded on the wrong factor and who's loading on the right one when you've got the items named like that, because that's what's going to appear in your report. Okay. So we go back to the data. I think this one, this one I've already cleaned missing value and reversed items that were reversed. So, yeah. Do you know how to reverse items, maybe before using the one that's already done? Okay, so if there's silence, that means you know. Moving on. Okay, so factor analysis, then we go to analyze, and then we go to dimension reduction. Remember what I said, that the exploratory factor analysis is really about reducing your dimension, your data dimension. So if you had 20 items or 20 questions you asked, but were all meant to be representing 5 constructs, then you want to reduce from the 20 to the 5 constructs before you run your data analysis. Do you mind if we take 5 minutes? I need to get some water because I'm the one who's busy doing the talking, so my throat is getting dry. Can we take 5 minutes?
Yes.
No problem.
Yes.
Okay, thank you.